Hey again everyone, back again with another logic board repair today. I have another machine that seems to be a common issue with these, and I was going to walk through with you guys and show you what the issue is. And if you were having the same issue, hopefully this can help you out. It may be different things because this kind of problem does have multiple different possibilities of what the issue could be. Like anything electronic, it can have multiple problems, so it's good to have some diagnosing skills to figure it out. But this one right here we have is a 13-inch MacBook Pro. This is the 2013 model, the 8203115 board. And this issue, I'll show you what it's doing. Get the adapter. And so you plug in the charger and it gets no light at all, as you can see. So there's no power to this board at all. And as you know, there's we've had some other videos that talked about this issue, checking your one-wire circuit when you're getting no light to the adapter to see if your circuitry for the one-wire over voltage protection circuit is working correctly. And in checking that circuit, you can diagnose multiple things like your SMC. Is it working? You can see if you're getting the correct voltage through your 3.42 volt rail, because you need that in the one-wire circuit. And all this, in that circuit, it talks to your power adapter to say, hey, you're getting the correct voltage. Will allow you to put the voltage in, and then that's when the adapter light turns on. So that's going to be the first thing we check with this. What I'm going to do is go ahead and remove the board from this unit so that we can get a full view of it, front and back, and we can diagnose it properly. So I'll be back in just a moment, and we'll do some diagnosing together. Alright guys, back. I got the board out now. We can examine the board, we can measure it with our multimeter wherever we need to. It's always good to take the board out, I think, especially when you have a problem like that where there's no power at all and you need to diagnose the board fully. Other issues, you can leave the board in and fix it. So if you know the problem is on top of the board, then you can do that. But when there's liquid damage or anything like that, it's good to take the board out so you can make sure that there's no liquid damage on the back side of the board or the bottom side, and make sure the whole board is ready to go. Anyways, what I'm going to do now, I'm going to aim the camera down a little bit so you can see what I'm doing. Again, I'm going to plug in the power adapter here, and you see we still have no light. So let me zoom in on that for you. We still have no light on the adapter. So this is a completely different MagSafe. Sometimes it's good to go ahead and try a different MagSafe board just in case the issue is the MagSafe board. And if that was the problem, this would be an easy fix. Just put a new MagSafe in there. But of course it's not. So we're going to continue diagnosing the board. And what we're going to do now is going to look at our 3.42 rail. Let me move you over to the schematics. So here we have the schematics for this board, and what I'm going to do, just type in one wire in my search bar here. And so this is our one wire circuit. You see this is our DC power jack plugged in here to our MagSafe, and this goes through the one wire over voltage protection circuit that I was telling you about. And one of the first power voltage rails we're going to check is our 3.42, the PP3V42_G3 hot. That rail is one of our critical ones to get the machine powered on, because without that we're not going to get any power from the MagSafe. So let's hop on over to the board view and let's do a search here for 3V42 and right here _G3 hot. Alright, so up here this is an easy place to measure the 3.42 voltage. So I'm going to go ahead and get you set up for that view. Let's see, let me move this under the microscope. And then let me set up the multimeter so you can see that as well. Okay. And as you see, right next to this connector here, we have these two resistors. And so that is our battery light indicator. That's what, when you press the button on the side of the computer and it lights up to show you how much battery power you have, that's where that cable plugs in. And then we have these two resistors right here. So we're just going to measure on this side here and see if we get any voltage. So I'm going to go ahead and plug in the power into the logic board. And of course we're not getting any light, but still we're going to measure and just see what we get here. So the black probe on ground, this probe here, and you can see we're not getting any voltage. So the next thing we're going to do is I'm going to check for a short to ground on that line. And I'm going to move this into resistance mode, like that. Move it up a little bit. It's a little bit lighter for you, I think. Okay. And now I'm going to put the red probe on ground. And then I'm going to touch one of these and see what it shows up. See, yep, it's a short to ground, so 0.001. That means that there's almost a straight, pretty much a straight short to ground on that rail, on your 3.42 voltage rail. So that's not good. That's the reason we're not getting any light on the back, on the MagSafe. So now we're going to look over the board and just see if we can figure out where this short's coming from. One of the first places I like to look is, let me show you the schematics again. And we're going to hop through, let's see, 3V42. And you can see right here on the, this is the, I think it's the block diagram is what it's called. Yeah, I believe this is like the block diagram. This shows you right away where, you know, the main components on the board and where it's all coming from. So you see this right here, 3.425 volt G3 hot, U6990. Let's search for that in the schematic. Take that off. Okay. So this is our 3.42 volt supply. So U6990. Now we're going to go over to the board view and we're going to search for U6990. Where is that located at? Okay, so that's the back side of the board, or the bottom side. And pretty close to the RAM bay, we have this little component here. So let's take a look at that and see what it looks like under the microscope. And I can just show you this again, so you can see both. Alright, so we're looking for this component right here. Tweezers, the component right there. And that component looks fine, honestly. I don't see any liquid damage around. I see a little bit of junk on it, but it doesn't look like it's been burned up or anything. So that component looks fine. So what we're going to do now is just move around the board and see if we can find any damage. And another thing I like to do, let me go ahead and do this. We're going to just do a search for 3V42. Just pull up the board view, sorry. And we're going to do a search on the board for that. You can see it lights up this area. Then there's a component over here. Let's take a look at that. And let's see, microscope. Let's do all view again. There we go. As you can see, it looks fine as well. It would be this component here. It looks fine. So let's zoom back out. Okay, it looks like we have a lot of components up here. This is underneath the heatsink area. Let me get a toothbrush and wipe off all that dust. It's kind of nasty. I still see no liquid damage or anything that would cause a short. And that's what we're looking for right now. I mean, we're just looking for something that we can visually see wrong with it. Okay, the next part we have over here on the other side of the RAM bay. Let's take a look at that. Oops, did not mean to knock you down there, Mr. Multimeter. Okay. So this component over here, and it looks fine too. Don't see any damage. There's another component up here. Nope, don't see any liquid damage there. Looking good. Alright, let's flip the board over and look up here. And this is kind of close to where we were before. Let's take a look and see. Alright. Do you see any liquid damage? What do you think? Right there. I do. I see some little liquid damage. A little bit of corrosion there. Let's pull this pad off, this wonderful foam pad. Don't know why it's there. I've never understood why it's there. I just know that when I get it hot, it melts and it stinks. So I'd like to pull it off. Alright, so looks like this component here, which I believe has to do with the audio, is liquid damaged. And let's see what that component is on our board view. Okay, so it connects to this over here, and guess what's on the other side of it? So we have PP audio CHS, and then we have on the other side of this little resistor or filter 3.42 underscore G3 hot. So this most likely is going to be the cause of our short to ground. So what I'm going to do is remove that resistor, or this capacitor. I believe it's capacitor. Let's check and see. Yep, C6405. Or yeah, 6405. I'm going to remove this capacitor and see if we lose our short to ground. I'm going to aim the hot air away from this connector. We do not want to melt that. That looks lovely, doesn't it, when it gets all wet like that? Alright, that component has been removed. Now, remember before we measured our 3V42 from these two places? Let's see if we have a short to ground now. We still have it on resistance mode. Red probe on ground. And black probe measure here. And look, we're getting 0.323 now. So we're no longer having a short to ground. So we have removed the short to ground. So what we're going to do now is we're going to replace this with a good capacitor, and because this probably is critical for our audio. And we're going to go ahead and do that now. So let me go ahead and get you on full view of the microscope. And I have a donor board to pull this part from. Let's see. And of course it has foam on it. So let's remove the foam. Okay, so we're going to remove this capacitor right here. Let's just measure and see what we're getting on this. And I'm going to measure it the same way I did that one on those two resistors right there, and just see what measurement we're getting. I think we got 323 on our 0.323 on our last one. 0.342. So I mean we should be good. I believe that was pretty close to what our other board was reading. So I'm going to go ahead and remove this capacitor. But first, before I do that, what I want to do is get this board completely ready to put it on, because I can't really set that capacitor down somewhere while I'm getting this ready, because I would end up losing the capacitor. So I'm going to just put some new solder on this. Okay. And now I'm going to remove it. From this board. Okay. Place it on our board. Alright. And now let's measure again and see what we are getting now after replacing the cap. We're still getting a good reading. We're no longer getting a short to ground. So now, let's do the fun part. Let's check and see if we get a light on our adapter. And if we get a fan span. So I'm going to take a fan, plug in a fan. We don't really need RAM in it or anything. We're not trying to get it to boot. We're just wanting it to power on. So let's see what we get. Green light and a fan spin. So we have fixed the short to ground, we fixed our problem, and now what we're going to do is get it plugged in back into the machine and see if we get a display. Alright, well, we're back. We got the board plugged back in, the RAM and everything back in it. Good to go. It's not screwed down or anything. I don't like to screw it down until I'm actually ready to make sure that the board is good. Because if something else is wrong, then you have to take the screws out again, so it's kind of pointless. Plug it in our power adapter. And you hear a chime, which is a good sign. I accidentally reset it. Sorry. Alright. And we have an Apple logo. And it is booting. So it looks like we have fixed the problem. Good to go. I don't really want to show you the screen because it's going to be the customer's user information. So I kind of want to hide that from you. But looks like we have fixed the unit. So good news. So I hope this helped you out. It's kind of nice to narrow down where the issue is coming from. Take the board out first of all when you have an issue like this, so you can check for liquid damage all over the machine. We didn't see any liquid damage on the underside of the machine, but we did on the 3.42 rail, which was shorting it to ground. That capacitor was bad. We replaced the capacitor, that's C6405, which removed that short to ground. Replaced it with a good capacitor, and we no longer were getting our 3.42 volt rail to be shorted to ground. Then it was able to send it to the one-wire circuit like it was supposed to, and get power to your adapter, which was allowing the machine to now turn on. So we fixed this problem. I hope this was informative for you and helped you out. Make sure that if you do have no voltage on your machine, that you are checking that voltage rail first, your one-wire circuit, because if you're not getting voltage, then you need to figure out why. You most likely have a short to ground, or that 3.42 power supply chip is not working correctly. Anyways, look forward to more videos, and we'll try and get some up for you very soon. And like I said, I hope you enjoyed the information. Have a nice day.